Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be talking about the reactions between acids and bases, also called titrations. Let's get started. Let's talk about titrations. So a titration is an analysis technique where one solution is used to analyze another solution. Now, an acid-base titration is when either an acid or a base is used to analyze an unknown solution. Acid-base titrations are also neutralization reactions. My picture to the right shows a setup for a titration. The titrant is usually the known solution. It is loaded into the burette. The burette is shown right here, and the titrant is put inside. You can see it is labeled. The unknown solution is the analyte. Now, it is usually put in an Erlenmeyer flask, and you can see right here it is labeled as the analyte. The titrant is added dropwise to the analyte. This is why we use a burette. The stopcock here allows you to add dropwise the titrant to the analyte. So during a titration, you are very slowly adding titrant to the analyte. You are trying to reach the equivalence point. Now, this is when just enough base has been added to neutralize the acid. At this point, the moles of acid equal the moles of base. Now, when you are doing a titration, you are watching the analyte, and what you want is something very obvious to show that you've reached the equivalence point. So we usually use an indicator. Indicators change colors at a specific pH. So you choose an indicator that will change color very close to your equivalence point. You can see in my picture to the right, it specifies that the endpoint has been reached because the indicator has changed color. It is important to note that we call this the endpoint, not the equivalence point, because while the indicator will change colors very close to the equivalent point, it is not exactly at the equivalence point. So the endpoint occurs when the indicator changes colors, while the equivalence point is mathematically where the moles of acid are equal to the moles of base. Ideally, these 2 points are very, very close to each other. Let's work a titration problem. A student is analyzing an unknown concentration of potassium hydroxide with a known amount of benzoic acid and needs to know the concentration with high precision. The chemical reaction and the student's data is given below. Calculate the concentration of potassium hydroxide for each sample as well as the average concentration. The student did 4 different titrations, and we have data for all of those titrations. Let me show you how to work through the math for a couple of these samples, and you'll see you do the same thing multiple times, and then we'll calculate an average. Before we start our calculation, I do want to point out that we have a 1-to-1 ratio in our chemical equation. We are going to need that. Now for our calculations, I'm keeping my data table. Let's take a look at sample 1. The first thing I need to do is I need to convert this grams to moles. So my 1.68 grams of benzoic acid, I have my molar mass, I get 0.0138 moles of benzoic acid. Again, remembering that chemical equation is a 1-to-1 ratio, I can convert my moles of benzoic acid to moles of potassium hydroxide. I'm trying to get to the concentration of potassium hydroxide. I have my moles. Let's calculate concentration. Here's my equation for concentration. Plugging in my moles. My liters of solution comes from my data table. I needed 32.28 milliliters to titrate sample 1. You can already see I have converted to liters. So my concentration for sample 1 is 0.428 molar. We will do the exact same thing for sample 2, except we will use the data from sample 2. So here's my data for sample 2. Just like before, I'm starting with my grams of benzoic acid. Using the molar mass, I convert to moles of benzoic acid. This time I get 0.00917 moles. I take my moles of benzoic acid. Using the 1-to-1 mole ratio, I get the same number of moles of potassium hydroxide. Again, I'm going for concentration of potassium hydroxide. Here is my equation for concentration. I just calculated my moles of potassium hydroxide. My volume comes from my volume for sample 2, and this time I get a concentration of 0.423 molar. Putting these samples side by side, you can see I'm doing the exact same math. I'm just starting with a different number of grams. And of course, I have a different volume for each concentration. The important thing is to make sure you keep the sample data together. Let's expand this data table to include concentration. So just for reference, here is our problem again. Here is our original data table. And now here is our data table with our concentrations. So you can see we're getting about the same concentration. Now that we have concentration for each of the samples, it's very simple to calculate the average concentration. So here is the average concentration. This is very common with titrations. You rarely do just one titration. You usually do sets of titrations. At their core, titrations are really about stoichiometry, so don't let the fancy vocabulary trip you up too much. Thanks so much for watching.